The new 2023 NEC text, for Class 4 circuit, states that, the portion of the wiring system, between the load side, of a Class 4 transmitter, and the Class 4 receiver, or Class 4 utilization equipment, as appropriate. Due to the active monitoring and control, of the voltage and current provided, a Class 4 circuit, considers safety, from a fire initiation standpoint, and provides, acceptable protection, from electric shock. The informational note, states that, a Class 4 circuit, is also, commonly referred to as, a fault-managed power circuit. A Class 4 device, is any device, connected to, the Class 4 circuit. Examples include, a Class 4 transmitter, a Class 4 receivers, or Class 4 utilization equipment. A Class 4 power system, is an actively monitored, and controlled system, consisting of, one or more, Class 4 transmitters, and one or more, Class 4 receivers, connected by, a cabling system. A Class 4 receiver, is a device, that accepts, Class 4 power, and covers it for use, by utilization equipment. A Class 4 transmitter, is a device, that sources, Class 4 power. The informational note, states that, a Class 4 transmitter, is different, from traditional power sources, in that, it monitors the line for faults, both line to line, and line to ground, and ceases power transmission, if a fault is sensed. Class 4 utilization equipment, is devices, that are directly powered, by a Class 4 transmitter, without the need, for a separate, Class 4 receiver. The receiver, is integrated into the equipment. This first revision, creates a new Article 726, for Class 4 power systems. The panel proposes, that this new article, should follow Article 725, and be numbered 726. The proposed new article, also includes, a new cable type, specifically for, Class 4 systems. Class 4, is different than Class 2 or Class 3, power-limited circuits. Section 725.121, A.4, indicates that, listed equipment, with a limited power source output, can be considered, a Class 2 circuit. UL 62368-1, requires the output, of a limited power source, to be power-limited. These Class 4 systems, do not limit, the output of the power source, but rather, the systems, limit the energy, and power available, into a fault condition, including human contact, arcing, and resistive faults. If monitored and controlled correctly, Class 4, can be as safe, or safer than, an LPS, but, because they are fault-limiting, rather than source-limiting, these systems, need to be treated differently, in the NEC, and in product standards. In Class 4 circuits, risks are mitigated, by limiting exposure times, short pulses, or fast shut-off times, and eliminating, repetitive impulses. In addition, they rely on, sophisticated monitoring, and control systems, to mitigate the risks, rather than, traditional mechanical protection, allowing for cabling systems, and installations, that are more like, Class 2 and Class 3 circuits, than power and lighting circuits. These monitoring, and control safety systems, involve solid-state controls, microprocessors, firmware, and software elements, that will require, fault analysis, critical software testing, and general functional safety evaluations. The Class 4 power system, is a fault-managed system, that relies, on an electronic handshake, to verify, that the power device, is present, and operating correctly, before greater than, Class 2 power is applied. Faults, result in immediate termination, of output power. Digital monitoring, is not a new concept, or unique, to these systems, to control and mitigate, safety risks. There are a number of standards, that rely on, digital monitoring and controls, in very critical safety areas, including, but not limited to, patient care equipment, electronic programmable circuit breakers, and alarm systems. The necessary requirements, for functional safety, including mean time, between failures, of critical components, software reliability, and the like, are well known. However, the complexity and applications, of this technology, warrant the development, of new installation code requirements. Unlike Class 2 circuits, which place finite limits, for sinusoidal AC and DC voltages, to reduce the risk, of electric shock, Class 4 circuits, need to consider, voltage levels, pulse widths, repetitive pulses, time to shut off, and stored charge, from cable capacitance, and equipment. This is not something an installer, or an authority having jurisdiction, can do in the field. There will have to be a reliance on the safety standards and the listing of equipment. A new informational note is added to the definition for Class 4 circuits to recognize its association with fault-managed power circuits. A new definition has been added to Article 100 to address Class 4 circuits. These circuits are different than Class 2 or Class 3 power-limited circuits. Class 4 circuits mitigate risks by limiting exposure times, such as short pulses or fast shut-off times, and eliminating repetitive impulses. Therefore, Class 4 circuits rely on sophisticated monitoring and control systems to mitigate the risks, rather than traditional mechanical protection. The monitoring and control safety systems involve solid-state controls, microprocessors, firmware, and software elements that will require fault analysis, critical software testing, and general, functional safety evaluations. This new definition is in direct correlation with new Article 726 for Class 4 power systems. Unlike Class 2 circuits, which place finite limits for sinusoidal, AC and DC voltages, to reduce the risk of electric shock, Class 4 circuits need to consider voltage levels, pulse widths, repetitive pulses, time to shut off, and stored charge, from cable capacitance and equipment. This is not something an installer, or an AHJ, can do in the field. There will have to be a reliance on the safety standards and the listing of equipment.